We're going to talk about congruent triangles in terms of angle side angle, which is what these letters here stand for, angle side angle. So let's look at what that actually means. So angle side angle, we get something like this. So I'm going to draw a triangle so we know what we're looking for. And for this triangle, I am going to mark two angles. So here's one angle, here's my second angle. And the next thing I'm going to do is mark the side. Now notice for angle side angle, this side is between the angles, so it's considered the included side, or in other words, the side that touches both angles, if you want to think of it that way. So here are my two angles. I can see this side here only touches one angle, this side here only touches this angle, this side here touches both angles. Therefore, this is my included side. So in order for you to use angle side angle, we're going to look for two angles in the included side, the side that connects to both. If you notice this, and then we have another triangle such that two angles and an included side match to the two angles and an included side over here, meaning they're congruent, then we know that these two angles, or sorry, these two triangles are going to be congruent. So I don't need to tell you anything else besides these three pieces of information for each triangle. And if you recognize that, or you're able to show this relationship between two triangles, you know the triangles will be congruent, and the definition of congruent triangles follows, where all the corresponding sides and the corresponding angles will be congruent to each other. So let's look at how we can see if we can find this in this problem here. It says here to determine if triangle ABC is congruent to triangle ADC by angle side angle, given that segment CA bisects angle BAD and angle DCB. So if I look at segment CD, they give me some information here. Segment CA bisects. Recall, bisect means to cut in half. And if you cut something in half, you get two congruent parts. So since we're bisecting angles, we're going to cut an angle in half. So it cuts in half angle BAD. So BAD is this angle here, BAD. So if you trace the 3 points, BAD, where A, that middle letter, is your vertex. So angle BAD is cut in half. How do I show that in a picture? Well, if it's cut in half, then I know I'm going to get two angles. So here are my two angles, and they're congruent to each other. Right? Because if it's cut in half, that means you have two congruent parts. In this case, you're going to have two congruent angles because the original angle was cut into two parts. It was cut in half. So that's how you mark it in a picture. They also told us that it bisects. So the same segment bisects angle DCB. Here's DCB. If I trace that angle, I can see that's this angle here. Right? DCB. So if I mark this angle that is cut in half, that means I'm going to also have two congruent angles. So I'm going to put my two arcs. I want to say these two are congruent to each other. So I'm going to put two tick marks here. I don't want to put one because I don't want to say this one is congruent to this angle. I just know that these two are congruent. Right? It doesn't really matter if this is congruent to that one, but we just want to show that these two are congruent because angle BCD was cut in half by this segment. So next, we're looking for, are these congruent triangles by angle side angle? So I look, is there any other information I can produce? Well, if I look at the picture, these two triangles share segment AC. So I know that segment AC, that's going to be the same thing as segment AC for both triangles. They both have that segment in common. So segment AC is congruent. And then the reason why I can say that is because of the reflexive property of congruence. So reflexive property of congruence. So how do I mark that these two segments are congruent to each other? Well, I can just put one tick mark here. And if you have trouble seeing it, you could always split up the two triangles. So if I look at triangle ABC, if I do a quick sketch of that, triangle ABC, and we mark that it had this angle, we had this angle, and we marked this segment. Then I draw a triangle ACD, and don't worry if it doesn't look perfect. So here's my triangle ACD, and I marked this angle here, angle CAD. CAD is this angle. That was congruent to angle CAB. And I can see BCA, this angle here, is congruent to angle DCA. So I mark this one with 2 tick marks also. And we know that segment AC from this triangle, they both had this side in common. You can see here that when I split up the triangles, they both have segment AC. So that's why we're able to say that they're the same, they're congruent to each other, because originally they were attached there. And then again, the reason is reflexive property of congruence. That's what allows us to say these two are the same, even though they didn't tell us that they were the same, right? Because we can see that they have to be congruent to each other because they're actually the same thing. So if I look here and I compare it to my angle side angle relationship, I ask myself, do I have 2 angles and an included side in one triangle that's congruent to the corresponding angles and a corresponding side in another triangle? Well, I can see here I have 2 angles and an included side that match 2 angles and an included side from another triangle. So what can I say about these 2 triangles? Well, I can say triangle ABC is congruent to triangle ADC, and the reason would be by angle side angle. Right, and you can see we provided all the reasons, we used the givens. So as long as you're able to show this relationship, you can conclude that the 2 triangles are congruent. And what does that mean for 2 triangles to be congruent? Well, it would mean the following. If you look at the notation, even though they didn't tell me, I know that segment AB will be congruent to segment AD. I know that segment BC will be congruent to segment DC, right? I can see that they didn't tell me that in the picture, but since angle side angle lets me know the triangles are congruent, I know this information here has to be true. So these 2 segments are congruent, these 2 have to be congruent, because remember, these are corresponding sides. If you look at the notation, these are the corresponding sides, and by definition of congruent triangles, corresponding sides have to be congruent. And then the other angles that I didn't talk about was angle B. That angle is congruent to angle D from the other triangle because they correspond with each other, and corresponding angles have to be congruent. And then the other, and actually that's it. So this is the information they didn't tell us, so I was able to add that. So if I wanted to, I could go back in the picture and say, well, now I know that this segment is the same as this segment. I know that this segment is the same as this segment. And I know this angle, I could put 3 tick marks, is congruent to this angle with 3 tick marks. So again, we didn't get all that information, but since we were able to prove the 2 triangles are congruent by angle side angle, we know all this has to be true over here. So that'll be my solution. And that's how you prove 2 triangles are congruent by angle side angle. And then we have one more situation. So in this case here, what I wanted to do is determine if triangle ABE is congruent to triangle CDE by angle side angle. So as we stated before, we're going to look for that relationship. Now notice they didn't say given that and then they give me some information, but I can see in the picture we do have something that was given. I can see that we have these 2 solid triangles, and that lets me know that segment AB is parallel. This is the symbol for parallel. So segment AB is parallel to segment DC. And I don't know if you remember this, but if I were to draw the line that passes through those segments, and I draw my other line that passes through those segments, right? And I draw my transversal. Let's say, let me look at this transversal here, BD, the line passing through BD. So I have this. One thing you have to recall is that if lines are parallel and they're cut by a transversal, where we have 2 lines and it's intersected, both lines are intersected by a 3rd line, I know the alternate interior angles, meaning this angle here and this angle here, those are going to be congruent to each other. So I can see here that this angle here is going to be congruent to this angle here. So I'm going to say angle B is congruent to angle D. And then that's alternate interior angles. So I just abbreviated it, alternate interior angles. And then we have angle, for the same reasoning, except in a different direction. This angle here will be congruent to this angle here. So angle A will be congruent to angle C for the same reason, by alternate interior angles. And it should be a theorem. So we put theorem. So alternate interior angles theorem. So I'm just basically, I don't know if I'm going to use it, but I'm just adding what I do know. So if you have parallel lines, this is one of the strategies you can use to, look at the alternate interior angles. And next, again, we're looking for angle side angle. So let me do a little side note that I'm looking for two angles and the included side that matches. So if I look at this, am I able to prove any sides are congruent? I have two angles. My included side would be this segment here. But I don't know if that segment is going to be the same length as segment DC. Right, I don't know that. And I don't know the lengths of anything else. I can add that this angle here, I'll put 3 tick marks, is congruent to this angle here. So that's angle AEB is congruent to angle DEC, and the reason for that will be vertical angles. So I'm abbreviating here. Vertical angles theorem allows me to say that these two angles are congruent. But again, like I said, I can see that I have 3 pairs of angles that correspond with 3 pairs of angles in another triangle, so they're congruent. But we don't have an angle relationship that we can look for to say 2 triangles are congruent, because that angle does not guarantee 2 congruent triangles. So for this one, we do not have enough information to conclude triangle ABE is congruent to triangle CDE. So I would say that not enough information to use angle side angle, right? We would have to I have an included side, but we don't know any of the sides that are congruent. So that's how I would end this one. So whenever you're trying to prove congruent triangles for angle side angle, this is, again, the relationship you're looking for is this right here. 2 angles and an included side.